Okay, thank you so much for the introduction. I'm Takahito Nakao from Toyobo MC Corporation, and we are the hollow fiber membrane manufacturer for the desalination, seawater desalination application. And I'd like to introduce today for the innovative brine concentration technology using osmotically assisted reverse osmosis system and our advanced hollow fiber membrane. So next, please. And firstly, I would like to introduce our OER system and hollow fiber membrane. And next, I would like to show our commercial project and differences. So next, please. And next, please. And next, please. So as you may know, the energy is one of the big challenges in the zero liquid discharge and brine management technology, as energy increases dramatically with the concentration level to be achieved. So currently, the membrane-based brine concentration technology like electrodialysis, membrane distillation, and forward osmosis is challenging to the thermal brine concentration technology with low energy consumption between 10 to 20 kilowatt-hour per cubic meter. So compared to these membrane-based brine concentration technology, so our OER technology is an innovative technology which enables you to concentrate brine more than 200,000 milligrams per liter and nearly saturated concentration we can achieve. So the OERO is the most energy efficient brine concentration technology I would like to highlight. So next, please. So this is the basic concept of osmotically assisted reverse osmosis compared to the reverse osmosis. So our OER process usually takes a brine from reverse osmosis, but the concept is fundamentally different. So unlike RO process, which takes a single solution across the membrane to generate the brine flow and permeate hardware, so we apply two solutions of same or similar salinity concentration across the membrane to generate the concentrated flow and dilute flow as well. So in this configuration, we can effectively minimize the osmotic pressure difference across the membrane, and we can reduce the hydraulic pressure to make water movement from one side to the other side with OER process. And with multi-stage configuration, we can concentrate brines to more than 200,000 milligrams per liter with the same operating pressure with the conventional RO process. So next, please. So as I explained, our OER process can be operated with a stage configuration like this, to sequentially increase the concentration level from first stages to the final stages. And in this configuration, we recirculate portion of the product to the permeate side of the membrane to minimize the osmotic pressure difference at each stage, osmotic pressure difference across the membrane at each stages. And in this configuration, we can concentrate RO brine to more than 200,000 milligrams per liter with one high pressure pump, because our multi-stage OER process can utilize the back pressure of RO, and we do not need any additional pump between the RO and OER. So next, please. And we already developed a commercial-sized hollow fiber membrane module for this osmotically assisted reverse osmosis process, and we call this membrane as a brine concentration membrane, BC membrane. So our BC membrane is a 4-port configuration with the inlet and outlet of the concentrated solution, which we call the shell side, and one for the dilute solution, which we call the bore side. And on the right-hand side, you can see the specification, and I'd like to emphasize our membrane material is a chlorine-tolerant material called the cellulose state. And also, we have very high surface area, like 600 square meters, with only one membrane module. And there are some feed water requirements, namely the pH and temperature, and also flux varies depending on the feed solution and the final solution shown in this table. So the next, please. And this is an example of the zero liquid discharge process. And by introducing our multi-stage OER process below here, we can dramatically reduce the thermal treatment capacity compared to the current zero liquid discharge process. And as a result, we can dramatically reduce the total energy consumption of the zero liquid discharge process compared to the current process. So the next, please. And I'd like to introduce a commercial project and track records using our OER process. So the next, please. So here is track records using our OER membrane module. And as you can see, most of our references is the wastewater zero liquid discharge process in China. And also we have the project in India for the agrochemical water treatment and textile water treatment and water treatment for the chemical industry. And the other track record is the salt production from the seawater using the membrane brine concentration system. And also currently we have the resin extraction and recovery process from the resin ion black mass. So I'd like to introduce one of our commercial project for the salt production in Indonesia from the next slide. So next, please. Okay, so this is the world's first large-scale commercial salt production plant using our ORO brine concentration process in Indonesia. And in this project, we are deeply working with the company name of Hylec. They have the technology to concentrate high salinity brines using our ORO membrane. And this plant consists of the ultrafiltration, nanofiltration, seawater RO, ORO, MVR, crystallizer to make a solid salt from the seawater. And we supplied more than 1,000 brine concentration membrane modules to the plant. And the daily water production of the plant is 27,000 cubic meter, and the annual salt production of the plant is 220,000 tons as a food-grade salt. And the plant is just under commissioning, and we will start full operation within this year. And the location is Cilegon, is the northwest side of the Java Island in Indonesia. So next, please. So this is a process flow diagram. The intake capacity is around 34,000 cubic meter per day as a seawater. And the next, please. So I would like to highlight that overall recovery of this salt production plant is 78% based on the seawater intake capacity. And the specific energy consumption of the total system is only 9.5 kWh per cubic meter. And next, please. And up to ORO, membrane brine concentrator system, the specific energy consumption is only 4.5 kWh per cubic meter water, yes, to concentrate the seawater to around 200,000 million per liter. And thanks to this ORO membrane brine concentration system, we can dramatically reduce the specific energy consumption of the total zero liquid discharge system. The next, please. Next, please. Next, please. So this is a three-dimensional drawing of our plant. This contains the ultrafiltration, nanofiltration, and seawater RO. And we use Memster UF membrane and Suez nanofiltration and RO membrane here. And next, please. Here is the ORO brine concentration system, 3D drawings. And we supply 1,080 pieces of the brine concentration membrane installed in the pressure vessel manufactured by the Protec Arisawa Corporation. And next, please. And after the membrane brine concentration system, next, please. We have the MVR crystallizer system manufactured by the GEA in Germany. And next, please. Next, please. So here is a picture under commissioning, and we already installed our membrane in the site here. And we already installed the membrane in the pressure vessel at site just last week. And we are about to start commissioning of the ORO membrane brine concentration system. And we will expect full operation within this year. So next, please. And next, please. And I'd like to conclude my presentation. And we developed the OR process and also the hollow fiber membrane suitable for this process. And we already have the commercial project in Indonesia for salt production, and the commissioning is now ongoing. And OR process can be applicable to the wastewater zero liquid discharge. and also the mineral extraction and the variable recovery like lithium extraction or lithium recovery from the end of life lithium battery like that. Thank you so much for your attention.